So our next speaker is Davide Rizza from UVI in Norwich, and he's speaking about on the constitutive role of mathematics in economic modeling.
Thank you very much. This title is not wholly inaccurate, but a bit misleading, because I want to focus on a couple of examples that illustrate what I take to be interesting phenomena that occur in the context of economic modeling as part and hopefully an extension of the discussion that has emerged, as Marina was telling you earlier, from the study of the contributions of mathematics to empirical inquiry in its various forms, which has importantly been developed by Pincock. But there is a lot more to be said. There is a wide variety of phenomena that differ substantially and occur at, in fact, a more elementary level than the average example Pincock discusses in his book, and I am hoping to show you why they are interesting enough to be taken into account. The ones I want to focus on today arise in the social sciences, but especially in economics, and they emerge. I will then explain why I'm talking about constitutive function of mathematics in a particular way, from the fact that it is often possible to have or be in presence of alternative ways of mathematizing a particular empirical setup or an economic problem or a design problem, and the alternatives will not be equivalent. So you may choose distinct mathematical resources in support of your investigation, and they are going to lead to different results, sometimes very widely different ones. So I take it that this is highlighting a substantive contribution of mathematics to this way of setting up models, which may be criticized as being, as it were, too mathematically informed perhaps, but I'm happy to talk about that issue maybe over the question period. I will skip over it for the moment. And constitutive then means here that we have substantive contribution, that what we are able to deduce in our theory will depend on the sort of mathematical environment in which our objects and problems are set. So the question I really want to examine is what happens when we have to choose between these different mathematical treatments. So it's not going to be really an account of the idea of constitutive role, but rather an account of what happens when you have a substantive role played by mathematics and how do you deal with the choice problem. This might resemble, I don't take it to be, it may well be similar. I will try to perhaps highlight a vague similarity, but I think it might be misleading to regard this choice problem as entirely analogous to a theory selection problem as we know it from philosophy of science, because this is strictly a mathematical treatment selection problem, which has slightly different features. And so bearing in mind this difference, one can nevertheless find an interesting interaction between the content of the models. I will show you examples that involve the problem of interpreting formalism, the problem of implementing normative assumptions as they interact with the choice of mathematical alternatives. A certain notion of theoretical virtue will actually emerge from this choice problem, but it takes, I think, a nicer form than the one we may be usually accustomed to from the philosophy of science literature, since, say, Kuhn, for instance, because now we are actually able to formulate, at least for specific problems, our theoretical virtues as explicit constraints that we may then seek to satisfy. So the problem of selection based on going for the approach that displays certain mathematical virtues may be one in which you already have the alternatives and choose the one that satisfies certain constraints. You can even regard the same phenomenon in a different way. You just pose the problem, how do we satisfy these constraints, and look for a solution. This can sometimes even be stated as a problem that admits to mathematical treatment, so we have this sort of mathematization of theoretical virtues in this particular context. It also has interesting consequences, I was saying, about the relationship between the content, let's say, of the model or its purpose and the formal resources that are involved to support the construction and investigation that is then prompted by the model. Okay, so I will focus on a couple of examples, but I need to tell you something about the alternative treatments I want to discuss in these examples. So I don't really know whether we needed this summary, but I thought it might be of some use when I started writing these slides. The alternative I will look at is between treatment of certain basic utility models, either by classical methods, the real numbers analysis, or using objects that come from a non-standard analysis. And so that's my alternative. I want to try and show why one might be inclined to choose, in fact, the non-standard treatment over the standard one in certain contexts, and the reasons why I think ours are of some interest. So this will hopefully give a first picture of how one can see mathematics as a substantive contribution to the regimentation of a theory the way it is articulated, at least in the type of framework I want to consider. And secondly, I hope this will be of some interest to philosophers of mathematics as well. This may well have an impact on the scientific practice, at least the theoretical side of scientific practice, because there are reasons why the choice of alternatives is connected to the intuitive representation of the problem one is dealing with. And if one has a theoretical framework that is believed to be the unique available, that induces a certain, let's say, preconception on what the intuitive problem will exhibit as its salient features. But if you can show that this treatment is not unique and there is a range of possibilities that give rise to very different ways of thinking about the same problem, that might also have an impact. This sounds a bit vague, but I will clarify that when the examples come up. So very briefly, you may all be very familiar with non-standard analysis. I will give you a very brief description of what the bits I'm interested in that will play a role in what is to follow. So I wanted to choose the approach that is normally called the Superstructure Approach, also developed by Robinson. There will be various ways to work with non-standard analysis, but here you start with a sort of set theoretical object that is rich enough to encompass the sort of things we would want if we were to apply the methods of classical real analysis to modeling. So we start from this basic collection of individuals or non-sets that is supposed to contain the reals, and then we iterate the operation of power set at various stages, innumerably many, take the union of this in a sort of familiar way. This object will contain the reals, function spaces based on the reals, and all the sorts of objects that a mathematical economist would typically use and adopt. What happens then is that in a number of different ways, for instance by constructing an ultra product or by a direct use of the compactness theorem, one can move from that universe U to another object called an enlargement that has a property I will sort of intuitively make use of later, which roughly is the property of concurrence, namely that if you have a finitely satisfiable binary relation in U, then it has a limit in the enlargement. To make sense of that and the idea of limit, which I'm using very informally here, think of the relation smaller than. By finitely satisfiable, I mean that if you pick finitely many real numbers, then you can find a single real that is simultaneously greater than all of them. By taking this limit, or by applying this concurrence principle that holds in the enlargement, you can actually find not only a simultaneous solution for finitely many, but for all of the inequalities of this kind. So you get numbers that are greater than any standard real in the original universe. If you read the relation of order the other way around, you get positive infinitesimals, for instance, so these objects will enrich, if you like, the universe of reference. So that the real sort of alternative here is played out between sort of larger set theoretical environment, but one based on the reals, the other on star R, which is sometimes referred to as the hyperreals, although they would be in an arbitrary enlargement, so you don't have the unique thing. But the two examples in which this alternative plays an interesting role, I think the second one is, for a number of reasons, more interesting, but the first one allows me to do some stage setting and hopefully can lead to interesting results. I will tell you what I know so far and what I hope is possible to do. That is an example that arises at the very beginning of microeconomics. So the first thing you see there is consumer theory, and the problem is to try and describe the choice behavior of an agent. Formally, that involves introducing a set of alternatives, and the agent will just say what his or her preferences are on that set of alternatives. Bundles of goods they are sometimes called. So you have a transitive and complete relation on this set of alternatives that is meant to describe the preference of an agent, a complete preorder. And the first thing you want to prove in this framework is just the existence of a utility function, namely a numerical assignment to your alternatives that gives you this strong representation of the preference. With the reals, you can do it, but there is a possibility of thinking of hyperreal valued utility functions. And what would be the reason to select one over the other? And you see that there is this choice of codomain available. There are some issues with real valued representation, namely, this I will probably gloss over. I can say more, but it would involve me in a lengthier discussion than I anticipated given the time apportioned to me for this talk. The real value case has situations where you can think of plausible multi-criteria choice relations that will not have representation on the reals, where I am assuming here that the space of alternatives is uncountably large, because that's what microeconomists start with. If you don't have that, then you may also have doubts about using real analysis to tackle these problems. But if you assume that you want to work within the microeconomics standard framework, then your representability will not be general, in the sense that there will be some preferences, transitive and complete relations, that do not admit any representation, and so you don't get unified treatment and generate two problems of classifications. Can you characterize the ones that are representable? We can in some contexts. Can you characterize the non-representable one? We could, involving ourselves in a certain amount of esoteric set theory. And secondly, I think perhaps more interestingly, there is an issue with looking for sufficient conditions that allow the existence, that entail the existence of a utility function, because they typically involve using structure on the space of alternatives that has no empirical interpretation. In the consumer theory basic setting, you only have an empirical interpretation for your relation. If you make it interact with some underlying structure in order to get sufficient conditions for your utility function, you end up having to formulate assumptions that refer simultaneously to things that are empirically meaningless and empirically meaningful ones. The relation and whatever the metric, for instance, appears in the underlying structure. If possible, that I think would be interesting to avoid, because then we would be able to keep disentangled very basic empirical assumptions from the formal constraints that allow the existence of a real value representation. So there would be a variety of choices. I mentioned here one, but I don't really need to dwell upon it. That was not the main point. So if we do this with real value utility functions, then we lack a simple relation between being a preference in the minimal sense that I have specified, and there would be criticisms in the literature against assuming more than the two assumptions I've given you of being a complete preorder and having the desired representation. So the problem is, or could be stated in the sense of the problem of choosing an alternative treatment, might be stated in the form of, can we find a codomain for utility functions that will allow us to represent every preference? And the answer is positive, actually. The first, well, as far as I know, the first proof of this has been provided by Heinz Scala in a 1975 monograph. Maybe there are earlier attempts, but I would not be aware of them. And there is a proof in Nares, but if you try to prove it in the framework I presented, the proof becomes much, much shorter, because your representation is actually the limit of certain finite utility functions that exist on your space in any case. And this is, therefore, you might think, a way of settling a problem of selection by appealing to theoretical virtues that can be stated in the form of a problem for which you can find a solution in a mathematical sense. This approach can be also extended to cardinal utility theory, and it allows, again, one to give representability in all cases with only elementary assumptions for your underlying preference relation. I don't know what, if anything, interesting can be at all done in the context of expected utility, namely when you make utilities and probabilities interact. It would be interesting to see what happens and whether one can sort of heavily simplify that treatment, but I do not have an answer to that, and I rather move on, therefore, to my second example, which is more articulate, and I think displays an interesting interaction between, as I was saying earlier, normative constraints, because many economic problems tend to have a very strong normative dimension, and mathematical resources being invoked in the model. So we have a utility problem again, but it is slightly different now, because this is based on making a choice over alternatives that have consequences in the future. Think of building or not building a nuclear power plant that will have an impact, at least for human species, that spans a very long time. So in that case, the idea is to think of sequences as being structured objects. Of the alternatives as being structured objects. Sequences, if you want to think of an indefinitely remote time horizon, then infinite sequences of time periods, each of which has an index that tells us what the welfare, level of welfare for, say, a population in that period is. That's a strong assumption, but let's assume, because that's not the selection problem yet, that this is a meaningful way of portraying this type of problem. If you have these sequences of utilities, typically taken to be real numbers, attached to a sequence of generations starting in the present, going on without end, then one may think of trying to compare them or make a choice between any two of them after an aggregation has been provided. So you have attached a label, typically a numerical label, to each one of them. So the numerical label will have an order, and that order tells you how you are to rank according to preference the alternatives. It's not going to be obviously an arbitrary ordering. We want the ordering to satisfy certain constraints, but I'm coming to that in a moment. Normally, again, one chooses the numerical labels in question to be attached to these utility sequences to be real numbers. And that leads to an interesting situation, I think. Namely that you can't, I'll say more about this, but you can't treat the present and future in an equitable way if you decide to choose your labels on the real numbers in the following sense. When economists discuss the problem of intertemporal choice, so choice involving a span of time and various time periods, they always, because they enjoy presumably including ethically unacceptable assumptions in their models, rely on the idea of discounting the future. Discounting the future means that if you have a certain resource, you get utility from it in the present, same amount consumed in the future will yield a smaller utility level. Now you may think that, thinking of Keynes' point that in the long run we're all dead, this may well be suitable if you're thinking of the consumption of an individual. You don't want to project the time the individual has to wait for consumption in the indefinite future. But if you think of environmental economics and the problems that arise there, then discounting the future, as already some economists have pointed out, is in fact a problem. And it is interesting that some of them do not go so far as to say that one should not discount the future, but just that one should keep the discount rate as low as possible. I think that this is due to the fact that the reliance on, in this case, real indices to represent utility sequences, and in an entirely analogous but mathematically more complicated case, the reliance on real value utility functions to solve certain optimal choice problems that concern, again, looking at the future, give rise to, in one way or another, series that do not have a sum. So you don't get solutions if you do real analysis unless you discount. So the discount is there for the series, if you like, to decay in a suitable way, quickly enough for it to have a sum. Don't want to say much about the technicalities because they're not truly relevant, but the intuitive point is simply that you don't get solutions to problems like finding an optimal consumption for a commodity over time, or ranking utility sequences if you do not discount the future, provided that you work within a classical framework based on the reals. This was pointed out already, that this assumption was unacceptable, was pointed out already by Ramsey, actually, in a paper from 1928 called The Mathematical Theory of Saving. But no attempts have been made up to date, apart from one published, a brief mention in a paper, and something I've been working on recently, to try and find conditions under which no discounting will be needed. And it turns out that non-standard analysis does help in this case, and you also get a simplification of issues because you sort of get rid of certain discriminations that would be based on the fact that if you rearrange the utilities in a sequence into a different order, then your evaluation might well be different because you want to get the greater utility earlier rather than later. On an equitable treatment, you don't do that. Essentially, if two utility sequences are obtained one from the other by a finite permutation of their components, they get the same index. If you try to aggregate them on the reals, satisfy this property, and in addition a monotonicity assumption, which is fairly sort of natural to assume, you don't get anything. There is no way to aggregate them this way. But if you do it on the hyperreals, actually you get many ways of doing it. So there is a rather dramatic change which allows us to implement, obviously theoretically, a normatively better, I would say, assumption, and it really depends ultimately to the sort of choice of mathematical resources we rely upon, as opposed to insisting that discounting should be applied. Economists have been vaguely aware of this when they study this problem. Interestingly, they pointed out this issue they had with trying to use real analysis. They thought there were not enough numbers to describe utility levels, which if you've seen the movie Amadeus, it looks like the critique to Mozart's piece. It has too many notes. In this case, we have the opposite, too few numbers. It's not a matter of cardinality, really. I think it's a matter of getting the right numbers placed to label utility levels. And it is interesting, this is not very sort of rigorous, but based on my contact with economists and referees, they tend to like the idea that economists would think of discounting the future quite naturally. I take it to be an impact of the fact that they would use methods that in order to yield solutions will need mathematical objects. That in order to know a solution will need discounting because of the mathematical object you use. But I don't claim this to be a sort of final conclusion about what economists think. It is clear, though, that they were vaguely aware of this, and it is true both of Kochman's work, which was on the problem of aggregation I've just described, and also in this recent paper that gives you the general negative result and points out the same thing. So we have a reason to think of the real numbers as ethically objectionable objects, at least, or an ethical reason to support the infinitesimal alternative. This treatment has a sort of generalization of counterpart in optimal control theory, but to the best of my knowledge, this is unpublished yet. So with this sort of ethical defense of infinitesimals, I will simply conclude my talk, and thank you very much.
Okay, so we already got 3 questions.
Thank you very much. It's only a clarification question. F star in non-standard is non-standard analysis is a conservative extension of standard analysis. So if you need non-standard analysis, it means to me, but it is a clarification for it, that there is something in the reality that we want to describe that in some sense has an infinitesimal value, which seems to me very strange. Yeah. So can you explain me how this is possible, that we need non-standard analysis even if we know that it is a conservative extension?
Oh, well, the idea in I think both cases I have in mind is to use a sort of hybrid approach where, I mean, there are various ways of doing it, but for instance, I suppose it's simpler if I take, in Naren's example, what he does is, imagine that he's given the set of alternatives and the preference defined on them. Then he picks the reals, he picks an ultra filter, builds up an ultra product of the reals, and then he says, that's the one I will use to map my values. Now the question is this supposed to have any sort of content behind it? In the case of preferences, there are situations like some lexicographical ordering. I mean, again, it really depends on whether, how idealized is the model. If you take lexicographical orderings non-representable like lexicographical ordering on the ordered couples of reals, that will not be representable on the reals, but then it has infinitesimal features in the sense that 0n for any n is smaller than 1, 0 according to this preference. So if you want to capture these features, you won't do it with the reals. And in the sense, the fact you don't get utilities on the reals is precisely because those objects. But I think there is a twofold issue. One is it acceptable to have uncountable generalizations as sort of suitable idealizations of actual preferences? I think there is another issue which would be to say, what are the generalizations of finite that are actually interesting and one could use in economics? But because in the standard treatments they seem not to care, for the moment I just wanted to point out that some of the objects they will use will exhibit infinitesimal features the way they present them. It is true of the other examples I've shown. There is a generalization of the theorem by Basu and Mitra that is based on the fact that you construct intuitively infinitely close objects and then you don't get representation in them.
Thank you very much for your nice talk. Usually, or maybe one of the usual criticism of using non-standard analysis is that R star is not unique. And so I guess maybe when you get your preferences with the codomain in the hyperreals, you get a non-unique choice of how this preference behaves. And this, I know this has been criticized in different fields. Do you have something to say about this kind of objection?
Yeah, I think that's a good point. I might make some remarks. In some of these cases, one way of dealing with this would be that there would be, I mean, it all depends how far you can go into developing your utility theory, and I would not have an answer about that yet. But the idea is that you get, for instance, in the case of preference representation, you actually get an internal function from star x into star r, and then you can use your embedding to connect your standard elements. So there would be a number of things you can do using sort of first order properties that transfer with that internal function. And I do not have an answer yet, and they may be enough for you to give the results you get in microeconomics, because many of them will be, let's say, as they call them, qualitative results about certain inequalities involving, say, derivatives. And the intuitive thought is that it shouldn't be a problem to lose uniqueness and work on an arbitrary enlargement, at least because much of this theory might not require specifically exotic resources. But this is a highly conjectural answer. It would be actually interesting to see what happens when you need to look for continuous representations, because that's what would be used in microeconomics. But on a measurement theoretic point of view, you could actually, this kind of result may well be good enough to do more, especially in the context of kernel utility theory.
Thank you.
Robert?
No. These are problems about coordinatization, aren't they? You've got a system of things and you want to somehow attach numbers to them or whatever. And you've got, what's going on here is rather complicated because you've got tremendous idealizations going on. After all, nobody's preferences are so exact that they can really be represented by real numbers. And also, the discounting of the future, I agree that it's unethical, as it were, to discount the future, But it's absurd to think that that means that we've got to regard the future as infinite, because just up to the heat death of the universe is still finite. And so long as it's still finite, it seems to me that you're not going to have the problem. So you've idealized the long finite to the infinite, which has caused your problems. But the other thing that occurs to me, even with the idealizations, really what's going on here is you need to look at the structure of the thing that you are coordinatizing. You need to do, as it were, what Hartree Field did to Newtonian physics, and consider the original preference relation and its logical structure, logical mathematical structure as a relation, just talking about people and their preferences or whatever. And then, strictly speaking, you could do everything with that. The numbers are just convenience. I mean, you ought to be able to, as it were, nominalize it, and just. I don't mean you should do this in practice. Coordinatization is extremely useful, but in principle, if you want to discuss what's going on, you ought to be able to, as it were, nominalize it and just talk about the preferences.
Yeah, on the first point, I do agree, and I think one issue perhaps with a fair amount of mathematical modeling, economic modeling, is precisely that it already starts with objects that seem to be there, if I may be cynical, more out of the unreflected choice of the mathematical economist than as an attempt to try and find the right idealization of finite. But because they, as it were, don't seem to take very seriously the fact that by doing so, they have this situation where you can present other alternatives and get different results. That's unfair because there are people who are working on computable economics, for instance, and have different approaches, not particularly to these problems, though. And I thought it might be worth pointing it out. I certainly would not be unhappy about nominalizing. One reason why they don't do that, economists, is that if you were to treat some problems using just a relation, then you would have to try and maximize the relation. You sort of don't have all of the properties that you might get if you have a real valued function for which you can find the existence and uniqueness of a maximum under specified conditions in the domain. So one of the reasons why they do it is convenience, but also the fact that you get an expressible theory of optimal choices. I don't know how much and how sort of neat can be done in an approach that would try to get rid of that. That would apply to the representation of preferences, but the aggregation was not a coordinatization problem because you just have a space of sequences and you map them on a totally ordered set, but they don't have an ordered structure, so you're not representing. You just want to be able to compare them, and you just choose a way of doing it that meets some conditions, and it cannot be done. But I mean, I think your points are both fair, and it'd be interesting to see what one could do. I don't know about the nominalization, how one might go about overcoming the issues they do overcome using the real value, for instance, functions, but it certainly is very interesting.
Andrea? We have 4 more questions, so I have to ask you all to...
It's really intriguing. Just a very quick thing. So this problem of how you represent things in a mathematical model, and the fact that you use a different mathematics in the model, and this can affect the representation of the empirical system that you give. Of course, it's across the board, so you can also have it for physical reality, and not social reality. So, so a very general question was, you talked initially at the issue of selection criteria for selecting the proper mathematization or the proper model. Now, in the empirical sciences, we have, well, most of us have at least the idea that we can choose the correct mathematical model to capture reality, cuts, joints, or whatever, the proper way of categorizing reality. Do you think that this question makes any sense in this context?
So,
not my question.
No, it's a very good point. You might think that maybe, and I would imagine economists think that this might perhaps reveal a stage that we need to overcome, and that a further refinement in economic theory might lead to sort of unique selections ultimately. But I do think that in many situations, even if we do not specifically concern ourselves with the problem of this high level of idealization, there is the issue that one is often dealing with a sort of highly normative framework. So, if you like, much of it really depends on what you want to get, if at all possible, and more than on what you are trying to describe. Because even in macroeconomics, you sort of seek to talk about, you think seriously of agents that have a complete control over the profit function and technology endowed with formal properties, which is not something you're going to get with sufficiently careful observation, I suspect. And some economists have pointed out how difficult it is to try and observe a profit function. It's not so. When one deals with this type of interaction among sort of rational agents in a strongly ideal way, I don't want to say that it is not meaningful, but I don't think that you get notions that allow you to attach, if you like, theory and empirical content in a way that would, for instance, be allowed by measurement. Right. So there would be several choices here that really depend on the sort of reality you want to design, and the fact that you want to show theoretically that it is, say, consistent to characterize certain type of interaction leading to equilibrium. So here there is a lot of choice. I tend to be skeptical of economists who see themselves close to, say, natural scientists. I think some economists close to them.
Thanks very much for that. I mean, this is really just clarification. You've chosen the Robinson presentation of infinitesimals where you take on the smooth infinitesimal analysis and go reductionistic with it. I mean, is there a particular reason for doing it? Is it just a standard presentation? Is classical reasoning really prevalent in economic mathematics? What's the reason for it?
I think it's, to a large extent, that, and the history starting roughly, I mean, mathematization began late in the 19th century, but the big change where it was massively introduced is the 1950s, I would say. So de Breur's theory of value, coming from Urbach's approach, and there he laid down a number of classical tools, and economists would just think of them as the received tools to follow that.
Albert?
Yeah, my question was somewhat subsumed by Robert's already down to the heat density units. But let me push it a little bit further. So this,
excuse me.
So certainly the assumption that we have an infinite time event horizon seems like questionable, right? And if you restrict yourself to finite sequences, then probably is it true that you could just get by with the old reals?
Yes, well, in that case you can get by with the old utilitarianism in the sense that you sum up your utilities and you're done. So that particular technique could not be done if you were trying to sum the reals in. But if you do the non-standard, the shift to a non-standard units, then you can find a sort of truncation of your extended sequence up to an infinitely large place, and you have a summation because you're doing it on a hyperfinite domain that gives you the summation for every partial sum, and that allows you to transfer. So the idea, I couldn't spell it out properly, but the thought is that hyperfinite is slightly better because it is closer to arbitrary finite in the sense that properties carries over, they overspill into infinitely large when they emerge for a finitely larger place. So there is that element of slight improvement. I think one could probably do better, but the problem there would be to try and mathematize a proper, manageable idea of arbitrary finite, I suppose. But hyperfinite, I think, would be better than the classical approach, precisely because it also does that a bit, whereas you wouldn't see it in reals.
So, it's a very, very naive question. I've been reading a lot in the literature in philosophy of mathematics, where you distinguish between a proof that explains something and a proof that doesn't explain. And in a certain sense, what you present reminds me of this distinction. So I was wondering whether you could say that the proof that the model, that the non-standard model would be kind of explanatory and the standard one are not. Could you apply this distinction to your...
I think that would work. I don't think I can offer a sophisticated answer. Probably I would go for a more naive answer, but there are cases in which one can show that non-representable objects will have infinitesimal features. And so, in some respect, when you solve a problem by a non-standard model, you're actually also pointing out that the reason why you didn't get the real treatment is precisely because you were trying to describe those features in a domain that will not allow them to be represented. So I suppose there is an element of that nature. It would be nice, actually. I think that's a very interesting point I should think more about, but it would be interesting to see something.
Because it would be a very nice link between what you do and...
Yeah, that's actually helpful.
So thank you again, our speaker.